Okay, let's speak about something interesting.
What's that?
Coils.
Coils.
Yeah. You see, those are coils. This is a transformer but has coils. So what is a coil? So this is a coil. That's the coil symbol. Or So what is so special about the coils? A coil is made with wire.
Okay.
Yeah? That means if you check a coil, depends on how much wire is there, the resistance is
Higher.
ohms.
Okay.
It's a wire.
Yeah.
How can it be higher?
Oh, okay.
You want to check a wire to see what resistance has? Or
Oh, okay.
what you are thinking?
I'm thinking if you have more wire,
Yeah.
the resistance would be higher.
Yeah, but you really need a lot of wire. Yeah, let's check this one. Yeah. So here you have basically two coils. Yeah, this is the output of the transformer. So check to see what is the resistance. So when you are on the ohm range, yeah. First you have the resistance of those wires. Those wires, they have a resistance.
Okay.
Yeah.
Yeah.
So if you touch this, the probes, I have like 0.8. So I know like 0.87. So I know my wires already has like 0.7. Yeah. Okay. So you have to keep that in mind when you check things. Now check the coils. What is the resistance?
124.
No, it's 1 point.
1 point. Yes.
Yeah. So basically it's 1.1, but you have to make minus 0.7, which is the wire resistance.
Yeah. So it's like 0.4.
Yeah, something like that.
Yeah.
But check this one, which has to be connected to 220 volts. Check this coil.
This is this has higher resistance.
Now how much?
15.
15 ohms.
15, yes.
Now 15 ohms, you need few hundred meters of wire.
Okay.
Few hundred meters, maybe. Anyway, somewhere around 100, depends of the wire.
Okay.
Because obviously, thicker wire has lower resistance. Tiny wire
has higher resistance?
Yes. So you need less wire. You know what I mean?
Yeah.
Obviously, if you try to use like a tiny wire, the power will be different. You understand? Good. So about the coils, how they are measured, what unit they are using to measure the coils. Henry. Yeah, Henry. And usually the coils, they come with millihenry or microhenry.
Okay.
You'll not have to do a lot with this Henry. But a coil is just a wire. That's what I want to have in your mind.
Okay.
Now, they have an interesting particularity. If you connect a coil to the power supply, what the coil it will do? It will create a magnetic field through the center of the coil.
Okay.
Yeah? A magnetic field. Now the coils, like what we have here on the desk, you can see this black thingy?
Yeah.
That's a ceramic material called ferrite.
Okay.
So what this ferrite it will do, or ferrite, I'm not sure of the English word. So what the ferrite it will do, it will store the magnetic field at how long you will have the power on the coil. And the moment you take the power from the coil, the magnetic field is gone.
Okay.
If you use like a core, the internal core, let's say metal, so you apply power. Soon as you take the power out, the metal, it will still retain the magnetism.
Oh, that's interesting.
Yeah. So let's say my screwdriver,
Yeah.
if we make a coil,
it's gonna keep the magnetic
Yeah.
thing. Yeah.
You understand?
Mm-hmm.
But this one, which is, I told you, it's a special ceramic.
Yeah.
Now, here comes the surprise. The magnetic field, what is stored, yeah?
Mm-hmm.
Soon as you take the power out, what do you think it will happen with that magnetic field?
Disappeared.
No, really.
No?
He will come back. He will come back in the wire, the coil wire. It will come back with inverse voltage,
Ouch.
and it's called flyback voltage.
Okay.
It's interesting, right?
Yeah. Yeah.
So soon as you disconnected, so you apply voltage, plus and minus, right?
Mm-hmm.
Soon as you disconnect the power, you'll have here minus, and here you'll have plus. So the coil, it will bounce back.
Mm-hmm.
Huh? It's not cool?
It is. Yeah. And I'm thinking what they are used for.
Why? That's the problem. You can't really use it. You can't really use it. And the people in electronic, they try to get rid of this flyback current. I mean, this is something what you don't want. I mean, you have a transistor, yeah?
Mm-hmm.
And we know transistor, plus and minus, the current is flowing on a certain direction.
Yeah.
You don't want inverse current
Obviously.
to your transistor, you know what I mean?
Yeah.
So the people try to get rid of this flyback current.
Okay.
So let's assume, you have two coils. If you have two coils, one near to the other,
Mm-hmm.
we can call this a transformer. You understand? Because the magnetic field from one coil, it will induce on the second coil.
Okay.
You understand?
Yeah.
Like the transformer, like this transformer, what we have here, this transformer. We have one coil here,
Mm-hmm.
then we have another two coils here. Basically, here are two coils. You have one coil and then you have the second coil. You understand?
Yeah.
But if you don't have two coils, like if you have only
One.
one coil, it's called a coil. Mhm.
Yeah.
So try to check those coils to see the resistance.
This one is a coil as well?
Yes, it is.
But where are the wires? Inside?
Yes. It's like a laptop coil.
Oh, okay.
Those small coils are used on electronic, like laptops, like TV boards.
Yeah, but how should I know this one is a coil? Because I cannot see any wires.
You can see the core. You can see the core. This is the ceramic core.
Oh.
I mean, if it's square and, it's looking like a duck, it's making sound like a duck, so it must be a duck. Another thing to check to be sure it's a coil.
What is a duck?
Another thing to check to be sure it's a coil.
Okay.
How you can be sure it's a coil?
Measure?
Yeah, it's a wire. It's like same like this, right?
Yes.
Yeah, check that. So we have like 0.6, basically is like you short the wires.
Yeah.
Yeah.
Okay.
Because it's just a little bit of wire, probably it's like, check this coil.
Why they're changing?
Because you don't wait or you don't touch.
I did touch.
You see? You are not touching. I can assure you that.
I am touching. Look, I'm holding with this hand right here, right? And I'm touching with this one. I'm touching it.
Check on the resistance. Now you are touching.
Okay, yes.
So it's like 0 ohms,
Yes.
right?
Yeah.
So you understand a coil is a wire.
Yes.
Because many people, they go confused. They check the coils and the coil is like that. It's like, okay, 0 ohms, so this coil is shorted. But how a coil can be shorted if it's a wire? You know what I mean?
Yeah.
Okay.
But wait, those are never shorted? They cannot get faulty?
How you can get short if you already have a short? They already have 0 ohms.
Yeah, true.
Yeah, they are getting faulty, but very rare. Or let's say the wire is getting shorted here, is getting burned, and you can you can see it's shorted. But like a laptop coil, I never find a coil faulty.
Okay.
I did found like in a big like TV boards, it is possible to find like a coil with shorted wire.
Mm-hmm.
But otherwise, this is just a wire.
Yeah.
They are pretty solid. Now the coils or transformers don't work with DC. If you apply DC, what will happen? The core, it will charge, yeah?
And stop.
And it will stay like that.
Yeah.
Of course, if you apply AC, you remember AC, the plus and minus is changing.
Yeah.
On that moment, the magnetic field, it will start changing, and you can add a second coil, and you have a transformer like this one. Yeah.
Yeah.
So this one is working with AC. Now let's try apply DC on this transformer.
But what's the point? You say nothing happened.
I know, but I want you to see. So we have the power supply on the screen. We have like 8 volts. It doesn't really matter.
And
you can hold with but don't touch the second one, yeah, because of the flyback current.
Okay.
Which usually is higher voltage compared with what you apply, but lower current.
Okay.
So check on the power supply what is happening. The current goes high, right? The voltage goes down. You know what I mean? It's like it's like a resistor, right?
Yes.
Try on this one.
I can hold it like this.
You can touch it. Nothing will happen. This is a small coil.
Okay.
It's like short. It's taking like over 4 amps. You know what I mean?
Yeah.
It's like you're touching the wires together.
Yes.
Now the flyback current. How we can prove the flyback current exists?
I don't know.
I'm just, the people got really confused about the flyback current. I seen there people building devices, catching the flyback voltage and using the flyback voltage, and they think the flyback voltage is actually
something else.
Is high. No, it's higher compared with the power you put in. So it's like a perpetual device. So it's like free energy.
Oh, okay.
There are a lot of videos, especially just have this thing. An electric motor has a coil, right? Yeah. Then you have relays. They have coils. So everything with a coil, it will have a flyback. Yeah. It will have when you disconnect the power, the energy it will come back with inverse voltage. Yeah.
Yeah.
Now we are touching but they just think, what about touching 300,000 times per second? You have a lot of flyback,
Yeah.
but always the flyback current, it will be lower compared with what you put in.
Yeah.
Yeah. So it's not like take more compared with what you put. You'll be surprised how many devices are on YouTube. People claim, different motors. People claiming actually the energy you take out is more than you put in, which of course is not true.
Okay.
So how we can prove the flyback current actually exists? Because you come here with the power, right? You disconnect the power, and instantly, and it is instantly, it's basically with the speed of light.
Okay.
You'll have inverse voltage on the wires. So how we can prove actually the flyback current is real?
Well, that's a good question. I don't know.
It is a good question, right?
Yeah.
What about So we have a coil, right?
Mm-hmm.
And my idea to prove the flyback current is real. We are coming with plus and minus here, right? Plus, minus. Okay?
Yeah.
And we are coming with a LED, yeah?
Mm-hmm.
With a LED on opposite direction. And obviously we need a resistor just to limit the current from the LED here and here. So the LED plus, it will be here. The LED minus, it will be here. So coming with voltage, I mean, nothing it will be short anyway. You try already with the power supply, yeah?
Yeah.
But when we are disconnecting the power, we should see the inverse voltage, yeah, coming in this direction, right?
Mm-hmm.
So when you apply voltage, the circuit is like that, right?
Yeah.
When you disconnect the power,
It will be.
on the other side,
On the other
right?
side, yes.
So we can check this.
Yeah.
You can make this transformer bounce.
I don't know. Let's see.
So you understand? It's taking power,
Yeah.
and you disconnect the power, it's bouncing back.
Okay.
Yeah?
Yeah.
So let's check. Let's see. We have here a LED. So we have an LED, right? I will connect the LED, but before we are connecting the LED, let's check which is plus and minus. I mean, I know this is plus, yeah?
Yeah.
So test with the power supply.
So this is minus.
Yeah, and probably red has to go to white. And you can't see. 1 second.
No, flip it over, like this. Yeah. So yeah, this is
Minus, and so the white wire is plus, right?
Mm-hmm.
Okay?
Yes.
If you spin the probes, try and spin the probes. Yeah.
Like this.
Yes.
Yeah.
Nothing.
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 Yeah.
Okay, so let's connect the LED to the transformer. So if we are right, that means coming with inverse voltage, coming with minus here and plus here, we should see the LED coming on.
Okay. That's.
So it will come on when you disconnect the power.
Yeah.
Now you can hold with one wire, yeah? To get electrocuted, you have to touch two wires. You understand?
Okay.
It's not bad. Probably the flyback voltage is somewhere around 50 volts with 8 volts and 5 amps.
Touch it?
Yeah. So keep it touch, and you see nothing happen.
Yeah.
Disconnect now, and you see the LEDs coming on.
Yeah.
You can see?
Mm-hmm.
So this is inverse voltage.
I'm not sure if they're seeing there. Let me see.
Yeah, it's you mean it's too fast, right?
Yeah.
Yeah, try now. Yeah. Yeah, you're right. Yeah, it's very short. It's very short. So you see, we do have flyback voltage.
Yeah.
You understand now how the coils are working?
Yep.
Good. Now let's go back to the screen. Okay, now let's assume you have a transistor, right? You have a MOSFET. It's not important, yeah? Then you have a coil. You have a coil. You can have an electric motor. You can have a relay, yeah? Mm-hmm. Anything which has coil, yeah? Now, when you disconnect the power, you'll have inverse voltage. That does mean you'll have minus here and plus here. No.
No, it opposite.
You'll have plus here and minus here, right? And the circuit cannot be close here because you disconnect the power, but can be close if you have something else on the circuit.
Yeah.
You understand? If you have more, you have a resistor here and so on. So flyback voltage is quite dangerous. Or think, yeah? Just think. Yeah, for 1 second, you still have the power here. Yeah? Mm-hmm. But your transistor is disconnecting the coil. I mean, you take the current out from the base or from the ground, from the gate. Mm-hmm. Depends what transistor you have. On that point, the coil, it will not have power. So what will happen? The coil it will bounce back with the inverse voltage.
Yeah.
So you will have inverse voltage on your transistor.
And it will get burned.
Can get burned, yeah. So how we can get rid of the flyback voltage? Because obviously to have this, let's say, it's no point having a coil here, yeah?
Mm-hmm.
But let's say you have an electric motor, yeah? So this is a motor. You understand?
Mm-hmm.
Same thing. Or you have a relay. A relay, it's a coil, yeah? And the coil is creating a magnetic field and is closing two contacts. That's how a relay is working. Probably you didn't learn yet about the relays. Okay, I'm just telling you. So how we can get rid of the flyback voltage?
I don't know.
But just think. Just think.
I'm thinking.
Yeah, just think. So you have a coil and you have a switch. It's a transistor. Let's say it's a transistor. Here you have minus, here you have plus. In this case, because you have a switch, it's not a big deal to kill the inverse voltage because you disconnect the power. Mm-hmm. Yeah. But let's say I want to get rid of the flyback voltage. How we can do it? What about shorting the flyback voltage?
Shorting?
Yeah.
How?
How do you think we can short this coil? Yeah. So we have to short. That's mean we have to short the coil. Yeah.
Mm-hmm.
How we can short this coil but still have the coil working?
No idea.
Yeah, but we learn. What about a diode? So the diode, it will flow in one direction, yeah?
Yeah.
The current.
Yes.
So let's say a diode here.
Okay.
You have the plus of the diode and you have the minus of the diode, right?
Mm-hmm.
Okay, so when the circuit is working normally, it cannot go, the current it will not flow through the diode because it's with the plus on this side, right?
Yes.
So the current it will flow on the circuit normally, yeah?
Yeah.
But if I open the contact, yeah, I will have inverse voltage here. That means here I will have plus and here I will have minus. And on that case, with plus here, I will have a current flow.
Okay.
You understand?
Yeah.
It's not cool?
It is.
Yeah, so that's how you
but
kill.
I never think about to put a diode there.
Why not? You can do anything with electronics.
Okay.
So that's how you kill the flyback current. Can we prove that? Maybe.
Maybe.
Let's try. Okay, so we have the diode here, right? Mm-hmm. Now try one more time to see the flyback current. So I said this is plus, so you'll come with minus.
Yeah,
like that. And let's see the flyback current. Yeah. Yeah, we can see the LED, it's lighting up. Okay, that's good. So now we'll come with the diode.
Okay.
This is the plus of the diode here. And the minus of the diode here. Okay, try now to see if you have any flyback current. Yeah? Wait, no, 1 second. So this is plus. Yeah, okay, sorry, it's my fault. No, it's my fault. The diode has to be on the other way. Because the inverse voltage does mean I will have plus here. Yeah? And I want to send the plus to ground. It's my fault, sorry. Okay, so we have the diode. Mm-hmm. The plus of the diode is connected here. Yeah?
Yeah.
So try now. Do we have any light on the LED?
Nothing.
Nothing. So you see, That's how you get rid of the flyback current.
Easy. Easy.
Getting rid of the flyback current does mean we can use actually, you know, like the coils, like let's say electric motor, relay, coil itself, yeah. Just tell me if you didn't understand something.
I understand.
So you understand, yeah? Always when you use a coil, you have to expect a flyback current.
Yeah.
Do we have to get rid of the flyback current?
Yes.
Not always.
Oh.
You will see when we're going.
You said you don't want that to fly back current.
Usually not. Usually not. But for example, the let's say laptop switching power supplies, they all you are using the flyback current to generate voltage.
So it is good.
Depends how you are using the coil.
Okay.
Yeah.
Yeah.
Depends how you are using the coil. Okay, everything is clear. Yeah.
Yeah.
Let's move forward.